enough. Friendly island.
Been a long time since I was little. Yeah, when I was really little. So I don't actually have that. Well, I went to Washington. I didn't really see but it's kind of like a Thailand. But I went home the first day. I went walking around.
O nauna I ka hala me ka lehua, he halele hua no ia, no naka no e. O ka uno ia e ano I nei, e li'a nei ho'i o ka hiki mai. A hiki mai no o kou, a hiki pū me ke aloha. Aloha e, aloha e, aloha e. Velina mai kākou, aloha. My name is Tony Marie Mapuanakawi, and I apologize. There seems to be some issues with the slideshow. I am currently a lecturer at Chaminade University of Honolulu. However, the work I'm doing with, and that I'm going to share with you today is through Imiloa. Imiloa Astronomy Center of Hawaiʻi is located on the island of Hawaiʻi. It's the Big Island, that's its more commonly known name. And today it's a collaborative partnership that I do with them. It's something that I've been doing for the past 3 years now. It's a community service that I do, something I like to donate my time and my knowledge and skills to them to help create curriculum. So just a little bit of background on Imiloa before we move forward. So Imiloa is a place of lifelong learning where the power of Hawaii's cultural traditions, its legacy of exploration, and the wonders of astronomy come together to provide inspiration and hope for generations. It's an integral part of the University of Hawaiʻi at Hilo, and therefore committed to improving the quality of life of the people of Hawaiʻi Island and the state of Hawaiʻi. In the fall of 2012, myself and another woman named Celeste Hopper began working on a project called the Mobile Science Outreach Program. And what it was, the goal of MSOP was to integrate the science that happens at Imiloa with mathematics, and then to bring that to the schools on Hawaiʻi Island. We were focusing primarily on Hawaiʻi Island because of the travel issues that we have. It's very difficult for Imiloa and very costly for Imiloa to have to take the things that we do and all of its equipment to outer islands, so to islands not on Hawaiʻi, or schools not on Hawaiʻi. So what came of that began the development of a STEM curriculum that we worked and created that taught through the Native Hawaiian culture. So because Imiloa is a premier astronomy center, and we have a full master navigator, Chad Paishan, that's the gentleman in your top left-hand corner, as well as the navigator in training, Kaimana Bartarse, who's on the bottom right-hand corner. Because we have actual navigators in residence at Imiloa, and we do so much with astronomy, it just seemed the natural connection to create a curriculum through Polynesian wayfinding and non-instrument navigation. So from that was born the math and science of wayfinding. So the math and science of wayfinding we created through the use of the 5 E's learning cycle model. as well as found a way to incorporate the engineering design process. So I'm going to talk about it through the 5Es learning cycle, and then I'm going to show you where we incorporated the engineering design process for the students. So just some background. So how we engage the students is by giving them background about Hokulea, background about the Polynesian Voyaging Society. And it began with a man named Herb Kawai Kane. And he refuted the idea of the accidental drift theory. So for those of you who aren't familiar with the accidental drift theory, it's the belief that Hawaiians accidentally arrive in Hawaii versus purposefully arriving in Hawaii. And so in order to refute that, he, along with another gentleman, they founded the Polynesian Voyaging Society. And they actually built a double-hulled voyaging canoe, and in 1976 had its inaugural voyage to Tahiti. And they did all of that with no navigation, non-instrument navigation. So we engaged the students by giving them some background, and then we talked to them a little bit about how we are going to incorporate now the Malama Honua voyage, which is the Hokulea's voyage around the world. So Hokulea, along with its sister canoe Hikianalia, in 2013 set out for a 4-year voyage around the world, and it turned out to be an excellent project for us to focus on when creating the curriculum. Primarily because being part of Imiloa and having the connections with navigators, we have the resource to be able to speak to navigators while they're actually traveling, talk to canoe members while they're actually traveling, and create that link and that network for the students and the teachers who eventually will start implementing this curriculum. So this is a map, and if you want additional information on it, the address is simplehokulea.com, as well as I've embedded that information into the slide presentation for you. So after that introduction, we talked to them a little bit about non-instrument navigation. We talk about the navigators themselves, the work that they do with trying to navigate without any instruments, using primarily celestial bodies and other natural resources. And so from that, my partner Celeste created a game called the Ways of Wayfinding. And it's an actual game that students participate in where they are split into teams, and they become waves, they become flight patterns of birds, they become the sun, they become the moon, and they become the stars. So in this game, the different teams are actually enacting the movements of all of those items that I showed you, all of those pieces of nature. And they're 2 leaders of the team who their goal of the game is to try and determine the patterns that they see. So based on the movements, based on how often the waves are moving, how slowly the sun and the moon are traveling across the sky, how the birds fly, like where their directions are going, where they're flying from and to, the leader of the team has to try and determine those patterns. And that's what really helps lead us into the explore part. So the next E of the learning cycle is explore, and this is where students now, they go back into their classrooms, so their science and math classrooms, and from a science perspective, they start learning about the relationship of Earth with the universe. So they learn about the rotation of the Earth around the sun and its relation to the sun, and how its rotation around the sun creates different seasons, which affects the tides, which will then affect how the navigators navigate at the given time that they're in. They also obviously learn about the rotation of the moon around the Earth, and how that rotation also does the same thing. Its relationship between the sun, the Earth, and the moon itself, and how that rotation, how that relationship also affects what the navigators use and the information that they gain in order to navigate from one place to another. And again, as we talked about, waves are very important, and so part of the waves that they the information that they learn about the motion of waves, the forces of waves, how waves move things in the ocean, how waves move throughout the Pacific Ocean, and how that affects where and how a ship moves. Especially because in the Pacific Ocean we have that one area known as the doldrums where there's no wind, and it's very difficult for them to navigate, which is why it's important, the information about the waves is important for them to learn and understand about. Again, so how waves grow, how waves are generated, and what waves do in order to help move the navigators. And the information that navigators have to take in from waves in order to be able to tell the actual steersman where to go, what to do, sails up, sails down, if they need to actually get out and paddle. And then of course, along with that, they're also learning about math. And so specifically they learn about angles, the relationships of angles, the various relationships of angles in math and geometry and algebra. They learn about transversals, and they learn about right triangles and trigonometry, circle trigonometry, and then they learn about the sine waves and cosine waves. And of course, they learn all this having just been introduced to navigation. But while they're learning this, they're still not sure what the connection is. But that becomes the next part. It's their job, the student's job, after gaining all of that information and knowledge, to be able to make that connection. And so they're the ones who are trying to do the explanation. So in the explanation piece, so the students begin learning about other cultural pieces that are a very important part of navigation. So this here you'll see is the Hawaiian star compass. You'll notice it has cardinal points, but very different types of markings than a traditional compass. But this is the compass that the navigators use. The students are introduced to this, and then based on this introduction, they're also learning about how that star compass is aligned with the canoe. So it's a little bit difficult to see here. I have a little bit better picture, but the canoe is here, and this is actually the way the star compass works. And based on this new learning, students are now having to apply what they've learned in math to be able to figure out if this is all a navigator sees, how are they supposed to determine which direction they're heading? How are they supposed to know which star house is rising in front of them, setting behind them, rising to their right or left? And when I say the star compass, these green and red dots, those are actual markings on the hokulea and hikianalia. And the students have to be able to transfer the knowledge that they just learned and that they've been introduced to be able to figure out this without this tool. So as you can see, a lot of it has to do with a lot of the geometry pieces, right? And that helps with the navigators to be able to direct them in the direction that they need to go. And then a lot of the science, so that all of this incorporates a lot of the math and science. Calculation-wise, it's definitely the math pieces. Science-wise, it's all about where the celestial bodies are rising and setting in relation to the canoe and the direction that the canoe is going. And which are important things that they need to know if they plan on arriving at the destination that they hope to arrive at. So it really is them learning about how it's very purposeful traveling. It's not, I'm gonna just put my canoe in the water and pray I hit land somewhere. They're purposefully traveling somewhere because they know, based on the signs that they have, based on all of the things, the data that they're collecting from nature, from the stars, from the celestial bodies, that they know they're headed in the correct direction. So that has, and then a lot more has to do with their learning about how to travel based on whether it's upwind and downwind, and all of the things that can and cannot happen with regards to traveling. So one of the things that they learn about is if you're traveling upwind, a canoe cannot sail in the direction with all of these degrees. So how do you calculate that? How do you have to take into account the tides? How do you have to take into account the motion of the waves to be able to adjust your sailing, to be able to still move in the direction you're going? So if you want to go west, I'm forward, but there's an upwind coming, how do you move the canoe? How do you use the sails to get your canoe to go in the direction you want to go, even though you're prevented from doing that based on wind? So these are all things that the students are working towards explaining now on their own, based on all of the information that they've learned, based on their new knowledge and the new skills that they've developed, how they're able to explain all of this type of information and movement with regards to navigation and wayfinding. Then we talk a little bit about, so the students also have to explain how the celestial bodies move in relation to the canoe and what time of year it is, and how the time of year plays a huge role in determining which stars they're going to be looking at, where exactly the sun and the moon will be rising and setting in the sky, and their location on the earth itself. How that makes a difference in the choices that they make while wayfinding. So here, just a little bit more. We talk about them with regards to the tilt of the earth and how that plays an important part in the travel as well. So I'm going to break here because I've kind of given you a lot of information before moving on. If there's any questions, just to check if there's any questions before I move forward.
So just to be sure I understand, this vessel is still moving around the planet?
Yes.
And they're virtually following it?
Yes.
And they're trying to determine where they are based on...
No, not necessarily. It's not necessarily a determination of where they are, because that information is readily available online. Okay. It's more about learning the ways of navigating, so how to use navigation without instruments, and all of the information and data that's required to be able to be a navigator, and how to use that information to help you get from point A to point B.
And again, the crew doesn't have any tools?
No. There's no... it's all non-instrument navigation. So no sextant, no GPS. Telescope, no GPS. Yeah, none of that. They do have electricity, but the electricity is mainly for being able to communicate to the students, because that's one of the biggest goals of Malama Honua, is to be able to educate people and to have that interaction and communication with the students around the globe. So this is for middle school, so 6th, 7th, and 8th.
I have a question.
Sure.
So when you're doing the math with them, like trade,
yes.
and all that,
we don't go into great detail, but we do introduce it to them because they're going to see it at some point, right? And that's our goal, right? Our goal is to help students to excel more in what they're doing in math, right? To take math beyond Algebra 2. And so that's why when we introduce it here and we show them the relevance of that math and how it's important in being able to do a cultural tradition, a cultural practice, we hope to engage them more so that they keep that, they retain that feeling of how it really meant something to them, so that they will be willing to say, oh, I remember doing that when I was in middle school. We didn't learn a lot about it, but they'll be more engaged with being able to learn it at that later level. Especially because it's not often, right? And that's one of our goals too, is to be able to promote cultural-based learning, right? And so, although students may see it at one point in their life, they may not see it again, but for us to be able to introduce it at any point in their life, so that they can see that relevance and have that desire and motivation to continue that learning, regardless of whether their teacher is someone who's willing to teach through culture or not. Any other questions before I move forward?
So this is a camp, or when?
No, this is, and I was going to talk a little bit about that at the end, but since you bring it up, I'll talk about it now. What we do is, our goal is to teach teachers and to have the teachers then take it into their classroom. So we will help to educate them on this specific curriculum. but also with the goal of we're teaching you skills that can be applied to other places so that you're not reliant on us creating the curriculum for you, but now you have the tools necessary to think about how anything else that you're teaching in school can be applied through the culture, can be taught through the culture. So the goal is to not just teach the curriculum, but to teach them the process of creating a curriculum like this.
Could you talk a little bit to the climate of, I guess, pressure to stick to standards, or how you've been able to integrate this kind of?
Sure. Well, a lot of what we create, we make sure does integrate standards, and it integrates the specific grade level standards that we're doing. So, excuse me. So this curriculum does integrate the Earth and its relationship to the universe in NGSS. It integrates a lot of their engineering piece of NGSS, and it also integrates Earth science of NGSS. Additionally, it also integrates a lot of the geometry concepts for math, as well as algebraic concepts of Common Core. So we're trying to be purposeful about what we do. We're not just creating this to make to get the engagement. We're also creating this to make it rigorous as well. Because as you mentioned, in Hawaii, we still are required to make sure that we're teaching to standards. So the units still have to be standards-based as well. And so we're very conscious of that as well. So we do work hard to try and do that.
So does it involve,
No, go ahead.
Does it involve you working with like the math and the science teacher?
Yes, so I'm a math teacher. I'm a certified math teacher, as well as I work with certified science teachers. And then, so it is a team that we work together to collaborate and create this curriculum, right? So that, right, it's not one person having to understand all of the standards. It's a team of us working to incorporate all of our mana'o, or our knowledge, to be able to create this.
And I was going to say, in Hawaii, the social studies standards are also in large part cultural based. So it's not out of place for teachers to be able to find, Ceci and I can talk about this.
Yeah.
To be able to find a place for it, because there is an emphasis in Hawaii state standards on cultural awareness and various grades.
Yes, throughout, you're right. I mean, I think that's typical for most states, right? Most states try and incorporate a lot of that state's history throughout the curriculum, K-12 curriculum, right? So we try to do the same in Hawaii as well. Any other questions before I move on? So in the elaborate piece, this is where we begin to introduce the engineering design piece. And it's not engineering design in the sense of engineering design. The students aren't building a object that can produce something or do something. What in fact that they're doing is they're learning to incorporate their knowledge and skills to be able to create something that can help teach others about navigation. So the problem that they're going to be tasked with as like their culminating piece is creating a scavenger hunt. But a scavenger hunt that directs students using the same knowledge and skills that navigators would use. And it's a way to be able to introduce the younger students in their community. So if the school that we're at doesn't happen to have an elementary school, then whatever elementary school is in their community, for them to be able to come learn about it through a fun way of a scavenger hunt. So this piece, and this is Ceci, so this is the partner that I work with in helping create this curriculum. She actually is a navigator in training herself. She traveled from, well, I forget where she got on, to be honest, but she helped to navigate the boat through to Samoa from wherever she got on, which I can't remember, so I apologize about that. But anyway, so we tell them the criteria and constraints, where they have to basically apply all of the knowledge and skills that they've learned about non-instrument navigation and the math and science behind non-instrument navigation to create a scavenger hunt that someone else can use to be able to learn about navigation. And it really is a place-based project, meaning that the scavenger hunt that they create, the maps and the instructions that they create is going to be based on their school. So it's the opportunity for students to be able to create their own Hawaiian Star Compass based on their school And so they'd be creating it based on the objects, the artifacts, the plant life, everything that's around their school to be able to find those solutions. So they would brainstorm possible solutions together. So by going to their school, walking outside, looking at the area that they actually attend school in, whether they're landmarks, whether they're significant blooms of plant life, whether they're significant buildings, and they're going to use that information to be able to create their own star compass, where they will indicate what landmarks are. They're going to talk about the wind that comes through. They're going to make observations about what time those winds come through, how the sun moves at that particular time of the day. All of that information will be gathered and collected to help them use that for their younger students in their school to be able to create that map. So they would model the prototype by creating a map and creating the skills that go along with it. Now, again, since this is a curriculum that we've just begun building and we're working to begin implementing into the schools as of next year, we don't have any of the actual artifacts of students. But that's definitely something I hope to be presenting on next year when we have this curriculum and teachers and students have begun participating in it. And then the final piece, evaluate, is exactly what they will be doing in the the engineering design phase as well. They're going to evaluate their work. They're going to take responses, some critique from the people who are actually using it. They're going to implement it to create something better and to make it a better map based on input and feedback that they get from the people who are trying it. Whether it be their classmates, whether they actually implement it with those younger students. It's all going to come together to be able to help them do a reiterative design on their map and their clues to make it clearer and better understood. And so the last piece that we add, and this is, in my opinion, a 6E, which I like to call extend. So it's my idea of how students will be able to take their learning and extend it beyond to be able to show more in depth about what it is that they're learning and to be able to apply it again. So it's a matter of being able to come to Imiloa and talk about it more, make presentations if that's necessary, to be willing to share their manao or their thinking about what they learned, how they learned it, and what that's involved with. Maybe even come to Imiloa and create scavenger hunts for visitors at Imiloa to be able to participate in while they're there. It's just some way for them to be able to get more out into the community to demonstrate their understanding of all of the standards that they've achieved, all of the knowledge that they've learned, and the skills that for them to be able to hone their skills. So that is what we're doing. That's the actual product piece that Celeste and I have been working on to take to the schools. The last part I wanted to just speak a little bit to had a lot to do with your question about the process. And it really is about trying to help teachers understand that it is possible to teach anything through culture. But the key has to be that they have to have that pedagogical content knowledge in place and really be solid with that and have a strong understanding with that in order to be able to do that. Without the background, because that's the first piece of the process. You have to know your content. And you have to know your content well enough to be able to understand, well, based on what we're doing here, I can see how something like this culturally would fit in. So as an example, something that before I actually moved onto higher education, something that I used to do in the classrooms, and I actually did it last year when I was with Virginia Tech, was hydroponics and being able to relate hydroponics to algebra. But in the process, they're learning much more than just algebra. I mean, we're able to relate linear equations and functions to hydroponics and aquaponics, but we're also talking about science behind the plants that we grow, behind the soil that the plants grow in, behind the growing thing, because I can't remember what those names are, but the growing pods, the grow pods that are used as minerals to help grow those. We talk about water quality. They talk about the fish that has to survive and thrive in there. And all of that becomes a math science lesson as well as engineering lesson, but I wouldn't have been able to create that if I didn't have a solid foundation in my content knowledge. To know that all of these things, the movement of water, the growth of plants, the growth of fish, all relates back to linear equations and to functions, and that they can be graphed, that data can be graphed and can be used to make predictions about how long it would take for a grow period, how long it would take before I'm able to eat the fish that I'm growing. And also, which is why that we try to stress that if you're lacking in your content knowledge, then the first piece that you would need to do is to strengthen that content knowledge. So that's another part of the professional development. You need to think about what it is that you need to learn to be able to create these on your own. Because the one thing that we try to talk about a lot and really impart on them is the fact that you can't always just take curriculum that's given to you. Because no matter what, that curriculum will in no way fit 100% of your classroom and the students in your classroom. So regardless of what curriculum you're actually taking and using, you have to modify it no matter what. But how much better would it be if, as teachers, they individually had the strength to be able to create their own curriculum based on their students and based on the knowledge that they have of their students, culturally as well as academically. So from both perspectives, to be able to create the curriculum that they need when they need it. You know, it's significant, really significant primarily for the elementary school grades, because those teachers are with those students 24/7. Not exactly, but I think you guys all know what I mean. 24/7, and they have to teach all subjects, right? When it comes to secondary education, so from middle school and high school, it's still very important because you can still adapt your learning for the majority of the students in your school. It's really trying to help teach these teachers that, especially if in Hawaii most specifically, also with this young lady who works with Native American tribes, the majority of the students in your classroom are not European middle-class learners. You know, they're very ethnically diverse, and they require a different style of learning. They require a different type of teaching for them in order for them to be able to relate to the information and then be able to take that and learn the information from that. So it really is about teaching them to teach through culture, not with culture. So the difference, the way I differentiate that is, it's not about teaching a topic and then talking about culture. It's not about talking about a culture and teaching a topic at the same time, but it's really about teaching the content using the culture as the context around that. But like I said, again, you can't get that without having a strong content knowledge. And that's what we try to do. So our plan is to, our next step in the plan, now that we finished the creation part, our next step in the plan is to now invite 5 schools who have graciously volunteered to pilot the curriculum, gather some data from that in terms of teacher learning itself, as well as student engagement, and be able to make comparisons